Buenos dias, estudiantes. 13.2 population parameters here. Just now starting to get into what we do once we have the data. How do we analyze this data? What does it look like? What does it mean? That's what we're going to take a look at here today. So here are some vocabulary terms that you should be familiar with. And first, population parameters. Population, a complete set of all subjects that is being studied. So who's there? Your sample is a portion of the population, randomly selected, that is used to represent the entire population. So here's a really easy way to remember. So if you're talking about a population, right, that means you can pretty much reach everybody. So say you wanted to target a specific school to see who the favorite teacher is or something like that. You can reach the entire population to figure that out. A sample would be, say you went around and want to know what Long Island's favorite subject is, right? You could ask a few different schools. That would be a sample, and then you can use that and kind of extrapolate that to grab the entire population. So population parameters, statistics used to describe the population. So here are some of the things you would need for that. First, that's the mean, that's average, and that's X with that little line over it. We call it X bar. Median, that's the middle. So once all of the statistical data points or numbers, you would put them in order from the lowest to the highest, and you would literally find the middle, and that's called the median. In the calculator, it uses it as MED. The mode is the value that repeats the most, okay? So the number that repeats the most. Standard deviation is the dispersion of values. So here's the easiest way I find to explain what standard deviation is. Say I have 5 numbers, right? And those numbers are 1, 7, 8, 2. Okay? I would say that that has a small standard deviation because the numbers are pretty close together. 1, 7, 8, 2 are all pretty close together. So that would have a small standard deviation. Let's say I chose these. 1, 88, 16, 32, 1, 88, 16, 32, and 50. That would have a large standard deviation because those numbers are all far apart from each other. And that's what standard deviation is. Now there are two different types of standard deviation or symbols or the way we do it. And that's this symbol here, X. So when you're looking at that, that's talking about the population standard deviation. So population standard deviation, and then with it SX, that's going to be the sample standard deviation. Okay, so depending on which one, which type of study you are, it depends on which deviation you're going to use. Your lower quartile is Q1, and that's going to represent 25%. That's the 25th percentile, which we'll get into a little bit later. The upper quartile, that should say Q3, that's going to be at 75%. That's at the 75th percentile, so that represents where 75% of the data is. Your range is the largest minus your smallest point, so your max minus your min. Your interquartile range is the third quartile minus the first quartile. Some of you might be saying, we've done this before, and you've done this in your algebra class when you went through statistics very briefly. So now using your calculator, you can actually do it. So there are two ways that you're going to be given the data. One of the ways would look like this. One of the ways could look like this. Either way, you're going to be doing the same thing, but now I didn't take my calculator out for this because it actually depends on which calculator you have, how you're going to do, well, I should say this point, right? So when you are going to do this, when you are given the data, whether it was they just list the data like this over here, or if they gave you a table like this over here, and if I jump real quick to the next page here, it might look something like this, where they're telling you a value and they're telling you how many times that value occurred. Now, in order to do this, what you would do is you would hit the buttons, stat, Then you would go over to the right where it says calculate, and then number 1 says vars stats. Okay, you would then hit enter. Now, if you have the old school calculator, okay, one of these guys here, right? If you have one of these guys, so if you did stat right enter, then, well, that's not going to work. How am I going to write it? That's the screen, right? Then your calculator is going to say 1 vars stat. All you're going to do is hit enter, and it's going to spit out this information, right? You're not doing this, though. Don't do this. It's not going to work. You're going to get an error. If you have the new calculator, you're going to hit that stat right enter thing, right? But it's going to be a little bit different because it's going to ask you, you're going to have to, it's going to give you a list, and you're just going to kind of keep hitting enter through it. And then you're going to get the same numbers as well. So either way, it doesn't matter which calculator you have, you're going to get spit out and it's going to look exactly the same. Now, why am I saying that they're different? How am I even supposed to put the numbers in? Well, over here it tells you. You're going to put the data in L1. So if I list the data, I would just go ahead and put all of these numbers in L1. New calculator, old calculator, just do it. So hit pause, throw all of those numbers in L1. Okay, we'll pretend like you just did that. Always double check, count, make sure that the number of numbers that are here, you put into your calculator, okay? Go ahead now, hit stat, right, enter, enter, stat, right, enter, enter, and you should have something that looks like this here. So the mean, like we just said, that's your X bar. That I'll call that 85.8. Your median, now again, you're going to be seeing the same thing that you see here. You don't see anything, hit the down arrow. Okay, hit the down arrow. And when you do that, it's going to say then median, it'll say Q3, and then it'll say max X. So hit the down arrow if you want to see more information. Just be careful, don't hit enter again, because then you're going to get out of it. So the median there is going to be 85. Your mode, that doesn't exist here. You'd have to look and see which numbers repeated the most. And 85 and 90 both repeated 6 times. So those are the numbers that would be the mode. You can have more than one mode. And your range, we said, is the max minus the min. And that was over here. It said that the min value was 70 and the max value was 100. So I would do 100 minus 70, and I would say 30. Then it says which standard deviation should we use, and I'm going to use the population standard deviation, and that would be this guy here, so that guy's sample. Now why did I use the population? Population is because in the question it says the scores on a certain test are listed below. Well, these are the only people that took the test, and I'm not trying to figure this out for more people. So there it is. That's the standard deviation I would do. Now, if you're still confused with the whole, what am I supposed to do with my calculator, stay with me because we're going to do another one. All right, so now these are actually the not the exact same numbers. So you're going to go ahead, you're going to put these numbers into your calculator. So hit pause, but now you're going to say, but I already have numbers in there from the last question. Remember, you can always hit second plus number 4, which says clear lists, and then hit enter. And that's just going to clear anything you have in your L1 and L2. So again, you can always hit second plus number 4, hit enter, and then that's going to clear anything you have in L1. So now go ahead and input these numbers, and when you do that, you should have 18 numbers in there. All right, good. Now, after you put all of your numbers in L1, by again hitting stat enter puts us in L1. We are now going to do stat right, go to right number 1, okay, that was calculate, and then you're going to hit enter, and you might have to enter a few times. until you see all of the information and under one bar stat. So the mean here was, turn the page, 83.72. Remember, you can go down a little bit to see what the median is, and that was 84.5. The range was the max minus the min, which was 100 minus 56, which is 44. Which standard deviation should we use? Well, all of the data points are in Mrs. Smith's class, so we're going to use the population standard deviation. So what is the population rounded to the nearest tenth? And that's going to be 11.7. So how do we interpret this standard deviation? So like we explained earlier, if your standard deviation is a small number, that means those numbers are pretty close together. If your numbers are far, or if your standard deviation is great, then you're going to have a large standard deviation. So this one here, 11.7, now let's take a look at this. We have 56, 68, 70s, 80s, 90s, 100s. So now the data is not super spread out, but it's also not super close. It's ranging all the way from 56 all the way to 100. And the data points have 50s, 60s, 70s, 80s, 90s, and 100s. And that's why it's 11.7. So while the standard deviation is not that small, it's also not that big. It's kind of like right in the middle there, right? So we would say these scores are slightly dispersed. Okay, so then they're not that close together, but they're not super part. It's not like we have 20s, 30s in there as well. So there's your standard deviation. So what percent of scores were within one standard deviation of the mean? So what does that mean to be one standard deviation from the mean? So no, didn't want that button. Okay, so first we have to take the mean. The mean in this case was 83.72. Now to be one standard deviation away, we want to add that 11.72. So then 83.72 plus, why did I write 72? Plus 11.7 is going to be 95.42. But you could also be one standard deviation the other way, okay? So that means I'm going to subtract 11.72. So you can, I keep writing that. I'm a terrible person. 83.72 minus 11.72, 11.7, and that's going to give you 72.02. So this represents all of the values that are one standard deviation from the mean, 72.02 to 95.42. So then you're just going to go ahead and count how many scores lie between 72.02 and 95.42. Now there are no decimals in this one, so basically you have to be greater than 72 and less than 95.4. So basically we're looking for all scores from 73 to 95, because that is larger than and that is smaller than. And if you did that and you went ahead and counted, let's see, 72, 72, 75, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 out of the 18. So 10 out of 18. Now, if you messed up on your rounding, you might have counted the 72, and you would have said 13 out of 18. So sometimes you just have to be a little bit careful, depending on how terrible your teacher is. That would tell you what kind of score you'll get. So you're going to have 0.555 repeating, so 56%. So again, it's just dependent on your rounding. Maybe you had a decimal somewhere. What percent of deviation is within two standard deviations of the mean? So now to be two standard deviations of the mean, we would have to go again another 11.7. We'd have to go again another 11.7. So then this number here would be 60.32. And then this number here would be, I don't know, I think I wrote 100. Yeah, it went over 100. So it would be 100. So how many scores are between 60.32 and 100? Well, that's pretty much all of them, right? All of these numbers. So it's just one of them that's not there. So for this one, it's 17 out of 18. It's like 0.94 something. So 94%, because remember, we're multiplying that decimal by 100. All right, so there you go. Exercise 3 is exactly the same as exercise 2, so it won't be too long. C and D we already answered, so this one's going to be a super simple one. Basically, it's taking those numbers and creating a box plot, and that's this here. Now, in a box plot, this was the minimum value, this is the first quartile, this is the median or the second quartile, that is the third quartile, and that is the max. Right? And we got that before, it's in our calculator. The mean we said was 83.72. The median was 84.5. The population standard deviation, that's this symbol here, was 11.7. The sample standard deviation, that's the SX there, that's going to be 12.0. The lower quartile, now that's just your job to know, okay, that it's Q1. And remember, you can hit that down button in the calculator, and that's going to bring you there. Some of you might say, but I'm hitting the down button and nothing's happening. It's because you hit enter too many times. Go back and do stat, right, enter again, and then just don't hit it too many times. So that first quartile there was 75. The upper quartile was 93. This stands for interquartile range, which is Q3 minus Q1. So that's 93 minus 75, and that's going to be 18. And your range is your, your range is your max minus your min, which in this case would be 100 minus 56, which would be 44. All right, there's your box plot information, and that's kind of that set there. In theory, what percent of data should lie between the first and third quartile? And is that true for this data set? So here's your first quartile, and here's your third quartile. So remember, this represents 0. The first quartile represents 25%. This represents the 50th percent. This represents 75, and this represents 100. Basically, each section in a box plot represents 25%. Okay, each section, doesn't matter how big or small it looks. Okay, you can have like a silly one that looks like this. Okay, each section represents 25%. Okay, no matter what it looks like. So if they want to know between the first and the third quartile, that's these two. So that's going to be 50%. So did 50% of the data lie between 75 and 93? So we're not going to count the 75, right? Yes, 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 no, yeah, no, 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 no. I said, well, how much did I say? 75? So it's just these numbers here, which was 8 out of 18, which is 44%. So it's pretty close, not exact, but 44% is between the first and third quartile. All right, so let's do some more practice about being standard deviations from a mean. All right, so now here we go with where things are going to get weird depending if you're new or old. It's the same question. They're asking for mean. They're asking for standard deviation, except they're not just giving you data points as a list. They're giving it to you as a table, right? So what you're going to do is you're going to second plus 4, clear out your list and what you currently have, right? Then you're going to get ahead and put this guy in L1 and this guy in L2. So hit pause, throw those guys in L1 and L2. Now that you have that in there, you're going to do, again, you're going to do stat right enter, right? You're going to do stat right enter, 1 bar stat. And when your calculator comes up, if you have the new calculator, it's already set to show you that they're going to use L1 and L2. Or you have to make sure you put L1 and L2 in there. if you have the old calculator, then what you have to do, so your calculator should say 1 var stat. You have to make sure you do L1 comma L2. Okay, so you have to physically put in the L1 and L2. If you have the newer one, it's kind of already set there for you. So make sure that you do that. Now you might be saying, well, where is L1 and L2? Well, L1 and L2 is represented in numbers 1 and 2. So if you look at the number 1, it says L1 right here in yellow. So you're just going to hit second button number 1, then hit comma, then hit second, and then hit number 2. And then they'll both come up, okay? So if you have the old school calculator, you have to physically put in the L1, L2. I don't know why I started doing these. I got all excited, I guess. Don't put the parentheses or brackets with your calculator. So it should just look like that. 1 var stat, second number 1, comma, second number 2. That's if you're old. If you're new, then it's there for you. Then once you hit enter, because you can hit enter now, then you can go ahead and pull out your information. So in this case, the mean was 42,660. Your population, because it's all of the employees, would be 16,567. What is the median of this data set? Okay, so you would hit the down button and go and find median, and it's going to be 32,000. Okay, so that's where the middle is. And it says, why is the median considerably lower than the mean in this data set? So remember, mean is the average. So it's like adding them all up and dividing by how many numbers. The median is just physically the middle. So if you look at it, the median, the middle, is right here, even though there are all these numbers or salaries below it. Well, the reason that the median is going to be considerably lower than the mean is because of all these rich people up here. If most of your employees are in the 32,000 range, and then you have quite a few in the 50s, 70s, and 100s, that's going to pull the mean up. Okay. So why is the median considerably lower? Because a majority, it's almost half, of the employees make $32,000. Then remember that mean got pulled up by these rich folk up here. Does more or less than 50% of the data set fall within one standard deviation of the mean? So we need to figure out where is one standard deviation from the mean. The mean is 42,660. To be one standard deviation, you're going to add 16,567. You're going to subtract 16,567. And that's going to tell you where the people are, right? So when you did that, here you're going to get 25,492. And here you're going to get 58,627. So this represents one standard deviation from the mean. So you go down here and see how many people make between this much money. Okay, so that's so 25,000. That's because you have to be 25,492. So you're out. You're within one standard deviation. You're within one standard deviation. 558,000 is before this, so you are not, and you are not. So these people lie within one standard deviation of the mean. How many people is that? 21 plus 14 plus 7 is 42. How many people are there in this? There are 50. So 42 out of 50 lie in one standard deviation. So that is 0.84. I'm glad I have a calculator there today. So that's going to be 84% lie within one standard deviation. Okay, so more. Okay, let's start moving downhill. So although we often concentrated on experimental studies where data is collected and means are found, many times we use statistics to represent results of a survey where we are interested in what proportion of a population shared a certain characteristic. These proportions are mostly expressed as decimals, but sometimes are represented by fractions. So, very complex definitions for what I'm about to show you. So a questionnaire went home to all juniors concerning their ability to bring and use mobile devices at school. The questionnaire constituted a census since all of the juniors were surveyed. Of the 742 juniors, 564 of them reported having web-enabled mobile devices. What was the population proportion for web-enabled devices? Well, 564 said yes, okay, because that's what you're asking for. 742 is your total. Divide those two numbers, multiply by 100, so it's 76%. So here's your decimal, here's your percent. Last one. The proportion of eggs that get cracked in a local egg facility is 0.023. If 2,500 dozen eggs are packaged in a factory per day, what should we expect to be the number of eggs cracked per day? So we know that the answer is 0.023. So in this one it was 0.76, so I knew how many there were and what the total was. In this question, I need to know how many cracked out of the total to give me 0.023. Now, you'd be quick to throw 2,500 in here as your total, but it didn't say that it was 2,500 eggs. It said it was 2,500 dozen eggs. So a dozen has 12, so you'd have to multiply 2,500 times 12. And that is going to be 30,000. Okay, cross multiply, and you're going to get 690. I did it. Okay, so again, there it is, our introduction to analyzing some of the data, looking at some of the data. A lot of it should feel kind of not that new to you, like you've done it before. And awesome, we're almost there. Almost done, everybody. Hope it helps. Have a good day.